Hold it. Let's start. The main changes were in this section from 2019 to 2016. The capacitors, the 2015 capacitors are the same. 105, 100 microfarad, 25 volt. So they're the same thing on this end. They never change that. Basically, it looks like the whole other end of the board is all the same. I'm gonna verify the values, but from here, this is the same. This diode right here, that's gone.
Oh yeah.
Over here, D102 is hardlined.
They didn't replace it in another location?
And if you look, this one, R103, on this one is gone.
Well, the only way to truly know conditions is to get a schematic. Because looking at the board sometimes...
This capacitor is the one in 2016's. They removed this capacitor. This was here in 2015, but there's a third version of this PSU that changed from 120k resistor here to a 75k, and they removed this capacitor. Now for the 2019 board, they brought it back, and it looks like a different value. This looks like the 75k, I think. Purple, green, orange, gold. But it's a 75k with the capacitor. This was a 120k with the capacitor.
Well, that could be a part of the bleeder, maybe. See, I don't have a schematic on it, so I can't really state exactly how it's being implemented.
Right.
No, it could be a bleeder cap, or it could be some other function, either with safety.
But it seemed like every time the 2016s, this resistor, when they went down to the 75k, would smoke. Dude, I've seen boards, pictures of guys' boards in my group, the MTK group, and the whole area around this resistor is brown.
Yeah, well, obviously, the reason why it's brown is because it's exceeding its power level, possibly.
Right.
And obviously, if they increase the value, then the current drops. If the current drops, then the power level drops too.
And this is a 6-year-old resistor.
Yeah.
On a 2015 board in 2021. It's a 120k, but it still looks fucking perfect.
Well, yeah, because if you don't push the shit out of it, it's not going to build up the heat. That's just common sense. That's Ohm's law. You know, so if you don't drive the resistor, because these resistors, they have a certain power rating.
Right.
And the more the power, you probably want to space it away from the board too, so it has ventilation.
I thought they would have done that.
Yeah, so, but that's all based on the where they're going to use that component and how they're going to use that component.
Yeah,
right?
I've seen the guy do that.
Oh yeah,
on
like
his repairs.
I built
this
amps when I did the amps, the one for Alex there. I know the thing was going to get warm, so I elevated it off the board for that reason, so that it will have adequate airflow. But you know, it's all relative in terms of how it's implemented design wise. So I can't say that.
But for the most part,
you know, when you say 75 and 120, I can't say that one is better than the other until you assess the schematic to have a better understanding of how they implemented this function of its use.
Everything else, for the most part, looks the same.
Yeah, for the most part, it's a switching converter basically. You know, that's your filter, your main input. Then it's going to get rectified, going into your cap. Your cap basically then has 170 volts peak, and then that from there has been going into this guy through usually a transistor or a chip That could be the optocoupler, which is, or no, that's actually, no, that's the switcher. Yep, that's the FET. So this little chip is your brains down there. It's controlling this guy. It's probably also the feedback loop. And that's all it is. And then this converts your 120 to a lower voltage on this side. And then it gives you all these rails that you see over here, which is this is your digital ground, I guess, 5 volts, minus 15, and analog ground.
48.
And then we got 15 here and a 48, yeah.
Yeah.
So 48 is probably for your microphone, your phantom
Yeah.
load.
Yeah. 15
Yeah,
for the
15
board.
is probably your op amps.
And
5 is
for
your USB, and your if there's any logic
and
LEDs
stuff.
or some
Yeah.
other logic that's on the 5 volt perspective. But yeah, so this is all low voltage side derived from here, and obviously, so it's a switching converter.
Yeah.
So
The biggest question that people want to know, the biggest answer to, can you take a 2015 board and does it make it into a 2019? Looks like physically, of course, everything's in the same spot. It looks like there's a few omissions. This is gone. That's gone on the 19. This one's gone on the 19. This is a different value.
Well, if you look at the way you wire it, see they got this end of the resistor going to the positive side of the cap, and then if you look at the other side, it's looks like it's going down over here through a diode, and I'm not sure exactly how that diode is implemented on the other part of it. See, this is where a schematic is nice to have, which I don't have. But I was thinking that it's possibly the possibility that it was a bleeder resistor, but it would have to return to this terminal somehow if it's going to bleed, per se, assuming it's bleeding this cap. Or it could be a resistor that has other implementations, which I can't really say, because right now I don't have enough inside data on this particular. But I mean, general, I know what the thing's doing. I can tell you that right now without the schematic. But reality is I can't tell you specifically the situation. I would have to, if the guy sends me a schematic from the company, I can look at it and say, yeah, okay, I know what's going on now. But
Right.
offhand, I don't want to say something that is put my foot in my mouth.
Of course not. No, man, it's Facebook. Nobody trusts anything on Facebook.
Well,
but I think it is possible.
I wouldn't say I know everything, but at least I've seen certain, you can tell the building blocks,
Like this capacitor and this capacitor are different.
Yeah, we replaced in the past, I think.
No, we were working over here.
Oh, okay, so we were working down here? Oh, okay, yeah, the low end side, okay.
But this and this is different. That's a different value, 100%.
Well, what's this one say? This one says... this one is 100 microfarads at 25 volts.
25 volts.
And what's the charge?
I'm not seeing it.
And this one is 220. So it's basically more than twice the charge. But then again, see, it's C103. And the question is, would that be the same on the board?
Yeah, C103.
C103?
Yeah.
But then again, even then, it has the same designation, but that doesn't necessarily mean it is implementing the same.
Well, that's just it. They've got stuff pulled now, right?
Well, yeah, this is why you need a schematic.
This is hardlined. This is missing. This is smaller.
Yeah. Well, I mean, they could have downsized the capacitance because maybe it wasn't necessary to have such a big charge for, assuming it could be just to filter for this chip.
Could it be that was what was burning out the 75K resistors?
Not sure.
No.
But remember, as I said to you earlier, 75K, 120K obviously increase the resistance. The current drops.
Right.
Current drops. I squared R is your power by Ohm's law, so you have less power dissipated in the resistor. Based on the fact that it's all things equal in the sense of the circuit design, right? You can't see until you know the circuit design. But using common logic, it would be obviously it would dissipate as much heat, so it won't burn out. So there's other reasons why it might have burnt out as well. I don't.
This was the biggest issue with 2016. They went through, I think there was 3 different date revisions. There was like a February 2016, there was a July 2016, if I'm not mistaken, or an August 2016.
I wouldn't mind seeing a schematic, and then I can give you a better insight into.
I would love to see one, but
because I don't really want to start reverse engineering this stuff right now. I've done enough of that in the past. I'm sick of it.
chances of getting one are next to nil.
But normally, because repairing something, usually you have an understanding of what's going on, and you can replace the same cap that was engineered for it. It'll probably work fine. But if it was a bad design from day one, then obviously the other issues.
But looking at the topography of the board and the general physical layout,
the general building blocks
you
are the same,
should be able to take something of this nature, take out the parts that you require to take out, replace it with the proper values, perhaps, right? That would need to be removed and filled. This would need to be changed out to a 75. Yeah. That would need to be downsized to that one.
If you look at this side of the board, too. Okay, I'm done. If you look at this side of the board, you'll see if the traces are all identical, too.
Right.
Because when they do revisions of boards, sometimes certain traces are not there anymore. They spin the boards in such a way that you have different configuration of electrical connection.
These ones all look good. They all look the same.
You see, like, look at this, Bill. You see, you got this geometric here, and you don't have it here. You see,
it's
different.
3, right?
See what I mean? So there's certain things about it that are not quite the same. Like this is
this was the ground. This was the ground.
Yeah. So that's what I'm saying. You can't just by looking at it, you can't
swap parts.
You can't say for fact anything until you know exactly how the electrical part is connected. The artwork is not the same. I can tell you that right now at a glance. There's a variance in the artwork. So that being said, you don't want to assume.
This is different. Eh?
Too many
is that
things.
What you're saying right here? This section.
Well, yeah, I see. If you look at the silk screening on the board, obviously there's a bigger square here. So, and what's underneath it? It's a resistor, and here it's smaller. But yeah, of course, it's a smaller silk screen. Does that mean it's lower power? Yeah, it is. You see,
because that's the resistor that was moved.
It's a bigger case, so it's more power dissipated. Obviously, because the bigger the resistor body, the more power it can endure.
Right.
For the most part, anyways, using common sense.
That's funny that they silk screened. See this diode?
Yeah.
They silk screened it hardlined here. That's that hard line in between.
Yeah. So they jump, but see, there's something coming. Oh yeah, that's a jumper. Yeah. So they took this point to this point, and then what did they do? They extended it to. Yeah, well, this on the other side. Where's it going? Yeah, it goes to this trace. So they're using, it's going down that trace, and that trace goes to this capacitor here. So yeah, they took it out, and they still kept it to the trace, and they're still utilizing that certain via there.
It looks
of a route.
Right.
Yeah, the biggest thing right now, if you saw the schematic between these two, you can pick it out real fast. Because then you see the electrical configuration at a glance. When you start looking at this, then you have to start, you have to start making your own schematic.
Yeah.
I mean, I can sit down and go through all that bullshit, but I'm not going to bother at this
point. Sit down with a voltage probe?
I've done that too many times before, and I just fucking lost interest in it. Dude.
Yep.
Sorry, you guys on whatever the internet there. But my view on this bullshit, no. I'm not an engineer, a PEng, but I could be one when I think about all the years I've put into this bullshit. But the reality is that I just spent too many hours in reverse engineering things in the past, and I lost my gumption of bothering with it.
But your opinion is they're basically the same power supply.
Oh yeah, of course. I mean,
They're
if
the
you look at the
same
build,
power
if you look at the
supply.
building blocks, this is probably to do with this chip. I'm going to tell you right now, Bill. Okay, this is something to do with this chip, most likely, because the chip needs a certain set of variables for it to operate, right? And basically, maybe they didn't need as much of a charge, or they didn't think they need much, so they downsized the cap. If this is a newer board, right?
Right.
So they respun it and they said, well, you know, it's not necessary. It's not making any effect, so we can downgrade on the cap, and you know, uh, but the same transformer for the most part, and the secondary part, you got your diodes converting, and then your first stage filters, and the second stage coils to remove more of the RF, and then the final output. Basically, that's all it is. Um, there's a
Pretty
feed
straightforward.
there's a feedback loop somewhere. Most likely in here. I'm not sure, but it's going to come back into here because it has to have some kind of a feedback mechanism to regulate these voltages. Um, Obviously, it's another chip here. I don't know exactly what it's doing at the moment. Uh, but yeah, this is all switching technology basically. All it's doing in a nutshell is taking 120, converting it to DC, being chopped up at high frequency through this transformer, then rectified at high frequency again. First stage filtration, a second stage of filtering here, capacitors, and then another set of capacitors. So it looks like it's
Smoothing, maybe.
smoothing out some more. Basically,
Yeah.
that's all it is. And then it gives you all these rails that as we went down the path, plus minus 15-volt rails, analog digital ground, 5-volt, and a 48 for your phantom load, and that's it. So once you have all those rails, the rest of your shit works. Uh, if the thing
Let's hope
is
this is the solution.
Yeah, so like for this guy here, if you want to replace this can be done. I mean, we can pull this out, put another one in it.
Well, that's just it. Do you think I should?
I can
I might as well just wait.
I can pull it out and put it in. You can keep it on a shelf for backup if you like.
Yeah, but I got the same ones. They're the same Ketuo
The
capacitors.
caps. Well, maybe the
I've got
cap.
Nichicons on the way.
Uh, you can keep the Nichicons. Well, those are Nichicons too.
Yeah, but they're only 80s. These are all 105 or 85s. These are all 105s for higher temperature.
Oh, you're talking about the.
Yeah, those are the 40. They sent me the wrong ones.
Oh. Well.
Yeah, I don't want to put a low temp capacitor in there, just have it explode again. Now, like I said, I could put 2 of these in and just call it a day, and just like you said, it's just going on a shelf ultimately, because hopefully this thing lasts for years.
Assuming it was just the one cap that screwed up on it, you don't.
Oh, they were both fucked.
Where was the other one? Was it this one?
No, the one that's missing.
If you want, I'll clean it out for you.